Today I'll solve one numerical problem on Venturi Meter. So here is the problem statement. A horizontal Venturi Meter with inlet diameter D1, so that is 200 mm, and throat diameter is given D2 is 100 mm, is used to measure the flow of water. The pressure at inlet is 0.18 Newton per mm square and the vacuum pressure at the throat is 280 mm of mercury. Find the rate of flow. The value of CD may be taken as 0.98. So now here are the given data. So inlet diameter is given, D1 is 200 mm, 0.2 meter. Throat diameter D2 is given, that is 100 mm, so 0.1 meter. Inlet pressure P1 is 0.18 Newton per meter square, so that is 180 kilopascal gauge pressure. And throat pressure P2 is the vacuum pressure, that is 280 mmHg, and discharge coefficient CD is given 0.98. Now calculation of absolute pressure at the throat. So vacuum pressure at the throat is given 280 mmHg. Pressure in kPa, so that is 2 mmHg into 0.13322 kilopascal per mmHg. So from here we can convert mmHg, so that is 37.335 kilopascal. Now absolute pressure at the throat, so that is atmospheric pressure minus vacuum pressure. So 101.3 kilopascal, that is atmospheric pressure, minus 37.3335, that is kilopascal. So that is nothing but 63.9665 kilopascal. Now here the value of P2, so that is 63.966 kilopascal, is the absolute pressure at the throat. This is calculated by subtracting the vacuum pressure from the atmospheric pressure. Now gauge pressure at the throat would be the absolute pressure minus atmospheric pressure, but since the throat is under a vacuum, the gauge pressure relative to the atmosphere is effectively negative. Now absolute pressure at the inlet, so P1 is 180 kilopascal gauge plus 101.3 kilopascals atmospheric pressure, so that is 281.3 kilopascal. So now we know P1 and P2. Now if we apply Bernoulli's equation between inlet and throat, so here is the Bernoulli's equation: PA plus half rho VA square plus rho G ZA is equal to PV plus half rho VV square plus rho G ZV. So ZA is equal to ZV. So we can rearranging for the velocity. So P1 minus P2 by rho is equal to V2 square minus V1 square by 2. Now rho is 1000 kg per meter cube, and P1 is 281.3 and P2 minus 63.9665 by 1000 and V2 square minus V1 square by 2. Now finally V2 square, if we simplify, V2 square minus V1 square is equal to 434.667. Now we know the continuity equation: A1 V1 is equal to A2 V2. So pi by 4 D1 square V1 is equal to pi by 4 D2 square V2. So pi by 4 will be cancel out. So finally we'll get V1 is nothing but D2 square by D1 square by into V2. So D2 and D1 is given, so that is D2 is 0.1 meter because 100 mm, so that will be 0.1 meter square, and D1 is 200 mm, so that is 0.2 whole square. So V2 will be into V2. So V1 will be 1 by 4 V2. Now plug this value, that V1, so V2 square minus, so here already we got that V2 square minus V1 square is 434.667. so here we plug V1, so 1 by 4 V2, so 1 by 4 V2 the whole square is 434.667. so now from here we simplify, we'll get V2. So V2 will be something 21.5 meter per second. Now if I know the V2, so we can easily calculate flow rate. So that Q will be CD A2 into V2. CD, that is given 0.98. A2 we have to calculate 5 by 4 0.1 whole square, so that is 0.007854, and V2 is 21.5. so finally Q will be 0.169 meter cube per second. So rate of flow is Q is equal to 0.169 meter cube per second. That's it. Thank you.